So this is the Make Noise Zero Coast. Let's take a quick overview of the different sections on this synth. On the left here, you have the control section as it's labeled here. You get two MIDI sections, and in the program A and program B, you can configure the MIDI in different ways. You get some additional functions in there, which we will check out in detail later on. So this is the MIDI A section, which is hardwired to control the synth. You also get a MIDI B section with additional CV and gate outputs. This middle section here is mainly the control processors. There are two CV ins here. One of them gets this attenuator. Then the two signals are summed below to the two outputs here. Notice this LED lights up when there is positive or negative voltage. Just above there's a stepped random voltage generator. The rate is controlled by the internal clock. There's a clock output, and you can see the rate on this LED here. You can change the clock rate by inputting a signal here. This internal clock can be set by just tapping a tempo on the program B button. Now the tempo of the clock is slower. So that's the control section. Next is the main oscillator section. There's a main pitch control dial here, and you also get a fine-tune dial just below. There's a linear FM input with attenuation and a 1 volt per octave pitch control input. There are two waveform outputs here, a triangle and a square. Right after the oscillator section, the signal is passed on to the overtone and multiply section. The overtone section adds overtones to the fundamental waveform. It uses both the triangle and the square waveforms to generate even and odd harmonics to the existing tone. After that, the signal is sent to this multiply section, which can generate additional harmonic content, making the tone richer. For both these sections, you get a dial each to control the overtones. There's a CV control for the overtone section, as well as a CV control for the multiply section. Nice thing here is that you get an attenuator to attenuate or invert the control signal. Next, you get a slope function generator. It's a two-stage function generator that can go into audio rate. You get a rise and a fall dial that controls the rate of the two stages, so you can create standard LFO shapes. You also get this response curve control, which can make the slope linear, logarithmic, or exponential. There are a bunch of jacks here for CV ins and outs. You can simultaneously control the rise and fall with an external CV in here. A gate signal here will trigger the slope. There are two output CVs. There's a slope output, which is the actual slope CV. Then there's an end of cycle that is like a gate signal that's positive when the slope is in its rise stage and 0 when it's in its fall stage. The slope can be cycled by turning on the cycle switch. So if I adjust the controls, you can see it cycling as the LED here is indicating that. The slope is normal to the multiply section, so the multiply dial is being modulated by the slope function. The slope is also normal to the overtone section, though it only kicks in when the overtone dial is above this even indicator. We'll explore that in more detail later on. So that's the slope section. Next comes the contour section, which is very much like an envelope generator. The onset is like the attack time of an envelope. Sustain is pretty straightforward. The decay dial controls the decay as well as release time. Then again, you get a response curve control dial, just like as in the slope section. For CVs, you get a CV in to control the decay release control. You can trigger the contour with the gate signal here. You will notice MIDI A gate is also normal to trigger this. There's an end of onset which can be used as a gate signal. And there's the actual contour signal that can be output here. You will again notice this is normal to the dynamic section. Let's move on to the dynamic section. So the audio signal comes in here. With this balance control, you can choose to listen to the pure triangle output of the oscillator when the dial is set all the way to the left, or you can plug in an external signal and you will hear that instead. If the balance is all the way to the right, you are hearing the overtone and multiply process signal. Finally, the signal goes to this dynamic section, which is like a low-pass gate. But unlike a standard low-pass gate, it does not use vectorals, so it responds to the contour much more instantaneously to get some really snappy amp envelope settings. Finally, you have a line level output with a trim part to adjust that level. There's also a dynamic output, which you should never connect to your headphones or speakers, as that signal is much more hot than line level and is meant to be used with other Eurorack gear. So right now, if there's a MIDI signal plugged in to the MIDI input, playing on the MIDI controller will control the 1 volt per octave on the oscillator and trigger the contour to produce sound. This is the fundamental. And let's set the balance to the overtone section. Bring in some overtones, and now we hear the processed oscillator. Whenever MIDI is received, the MIDI indicator lights up, so you know the synth is receiving MIDI. Also, if the synth is producing an output, the dynamic section LED will light up. Cool. So that's a quick overview of the synth. Moving forward, we will dive deeper into each section and learn things more in detail. Stay tuned for lots more.